the ones that would like to follow more, because the 3 parallel topics will actually be tackling similar matters, but that's the way it is when there is a lot of interest in on this topic. So in our case, we have 5 presentations in our breakup, and since we have 10 minutes per presentation, I would like the presenters to keep their presentation time to somewhere around 8 minutes. So we will have at least a couple of minutes at the end to answer the questions. I call upon all of you to use the chat during the presentations to ask the questions, so we can then quickly ask the presenter at the end of each session. I will announce the presenters and the presentations each one by one, since we do have at least 10 minutes per presentation. In a shorter sessions, we would do it all of them at the beginning. Nice. Now we can see it. Nice. So without further ado, I would like to start with the first presentation in this breakout. The breakout is called Interoperability Challenges to Increase the Service Offer of the EOSC Portal, Perspectives from the INFRAEOSC Call 7 projects. And we'll start with Nadia Tonello. She is the head of the data management team at the Barcelona Supercomputing Center, a huge center focused, employing a lot of people in Barcelona. And, Nadia has been working there since 2018 and working on projects like EU.CDI, EOSC Hub, EOSC Synergy, and of course the DICE project that she will be presenting, as she's a dear colleague at the EOSC Association General Assembly, representing her home institution, the Barcelona Supercomputing Center. So Nadia, the floor is yours.
Thank you very much. Good afternoon, everybody. I will present you the DICE project use cases, in particular the integration work of interoperable data and services with communities platforms. Next slide, please. So as you might have heard this morning from Peter Dorn talk, DICE is an INFRAEOSC 07 project for enabling European storage and data management infrastructure for EOSC by providing generic services to store, find, access, and process data in a consistent and persistent way. At the same time, the project aims at enriching the available data management services. Most of them are EU.B2 services, as you have heard, to better support sensitive data, long-term data preservation, and the connection of data services with computing. The project provides resources for each service under the virtual access mechanism, and they are accessible on the EOSC portal, of course. Next slide, please. So part of the project goals are reached with the integration of generic data services with communities platforms. The integration activity will demonstrate, first of all, the effectiveness of the data services we are offering, and they are offered to specific use cases. And also, this integration activity validates the process of enabling customized data services for scientific platforms by coordinating activities and resources provided by different European institutions. The data services are tested and improved with the integration of thematic and disciplinary platforms. The benefits, of course, are multiple. It will create success stories, first of all, and this will stimulate the engagement to EOSC of new users and new communities. And on the other hand, it will help to establish a structured and open and flexible mechanism for researchers to advise and orient the services providers. In fact, communities inside but also outside the consortium will have a mechanism to formulate requirements and give feedback to the services. One consequence of the integration of community platforms with the EU.CDI services is the growth of the data interoperability and of the services offered in the EOSC portal. Next slide, please. So here you can see the composition of the DICE consortium. Most of the partners are service providers, and they are offering about 55 petabytes of storage behind the services. But there are three partners that are representing in DICE three different users communities. And they are ICOS for the community of environmental sciences, Astron for radio astronomy, and UCL that together with SURF and BSc represents the community of biomedicine. So the three communities participating with three very specific use cases focused on accomplishing the objectives I've just explained. Next slide, please. So the first use case is provided by the Comp Biomed Center of Excellence community. The Comp Biomed platform focuses on the development of applications for biomedicine with the intensive use of computational resources, in particular of HPC. And the use case consists on the development of a data management workflow to permit the simulations using large data sets in HPC centers. And they are preparing for getting ready for simulation at exascale. This use case is treating just synthetic and simulated data, but has an interesting possible extension to sensitive data, and preparing the workflow to be used also by medical centers in the future. The services involved are B2Share, B2Handle, and B2Save. B2Save allows for data staging and the safe replication of research data between HPC centers, in this particular case, between BSc, where the simulation code is running, and SURF, that is the Comp Biomed archive site. The B2Handle service is used then for the generation of the PIDs, and the archiving will be facilitated also on tape for the long-term preservation of the data. The data then is published at UCL, where the discipline-specific metadata schema is going to be integrated with the generic service B2Find for data discoverability, and B2Share will be adopted for data distribution. Next slide, please. So this is the second use case. It is provided by Astron, and it is related to data management of data produced in the context of LOFAR. LOFAR is a radio telescope network with a mature workflow to manage the instrument data, while the science level data is generated using EGI-ACE computing services. That data process reduces considerably the initial volume of the data, so the requirement of science level data management are different from the instrument data ones. And this use case consists exactly on providing a generic repository for scientific data products for safe storage and discoverability, and also distribution connected to the LOFAR long-term archive. The generic services to be integrated are B2Share, B2Handle, and B2Find. B2Share is adopted for distribution of active data. Initially, the data archive is centrally located at SURF, but it will be designed to be scalable and reach petabyte capacity, in a couple of years. B2Find and B2Handle will be then integrated to widen the findability of LOFAR data using a metadata schema that is following the virtual observatory standards, and the results are also uploaded at the virtual observatory, but also using B2Find, they will become findable in a non-disciplinary specific service. So next slide, please. The third use case consists on integrating the platform of ICOS, the Integrated Carbon Observation System, with UDAT services for safe storage, staging of data to computing platforms, and publication of data sets resulting from the analysis of the research data as an alternative for publication data in addition to the ICOS Carbon portal. The final result of this integration work will be an extension of the ICOS community platform into a benchmarking environment of generic UDAT services as B2Save, B2Handle, and B2Share. In this work, all the FAIR principles are addressed, not only interoperability. In particular, this use case addresses the reproducibility aspect. So then I come to my conclusions. Yeah, I'd like to conclude with this summary table. The DICE project is working at 3 complementary use cases for the integration of generic data services with 3 community platforms: Biomed for biomedicine, LOFAR for radio astronomy, ICOS for environmental sciences. The objective is to create success stories, enhance the interoperability of the data with the usage of generic UDAT services for data analysis, sharing, discovery, and for data preservation. Metadata and semantic standards are guaranteed by the disciplinary communities platform maturity. Interoperability is then broadened by the adoption of generic tools like B2Find for publication and data accessibility outside the pool of users of the disciplinary platforms. And with this work, we aim at attracting new users to EOSC, improving EOSC data services composability, and also enhancing the interoperability and the chances of interdisciplinary use of this data. Thank you.
Thank you, Nadia. Thank you very much for the presentation and for keeping up with the time limit. I don't see any questions in the chat, but I would like to ask about what were the biggest interoperability challenges. I suppose that the part of the data was quite well interoperable based on the B2 services, but I suppose there were some challenges maybe in the computing part or integration with the computing elements.
Yes, the interconnection between data services and computing and, for example, HPC services, that we know that they are a closed environment for accessing. So it's quite a big challenge, but there are a lot of efforts, and we are working in collaboration also with other initiatives to make this new system of integration of data services and HPC services as smooth as possible for the users.
Thank you. That's very encouraging to hear from the user point perspective. Thank you once again.
Thank you.
We will have some wrapping up at the end if there are questions that come up during other presentations. There is a question. It would be also interesting to see if the integration of astronomy in B2Find could be developed. It's a suggestion from Francois to suggest integrating B2Find within the astronomy community. I think it's a good suggestion. So let's continue. Then the next presentation is OpenAIRE Connect Research Community Dashboard, and will be presented by Alessia Bardi. Alessia is a researcher at the Institute of Information Sciences and Technologies at the Italian National Research Council and a product manager of the OpenAIRE Connect services. So Alessia, the floor is yours.
Thank you. Thank you very much for this introduction. So we can start from the next slide. Thank you. And I will present you the OpenAIRE Connect service. And OpenAIRE Connect delivers on-demand open research gateways for research communities. And the goal is to lower the barriers that hinder the adoption of open science practices in the research communities, in particular the literature and data deluge, the dispersions of research products which are scattered across different repositories and sources, the lack of community awareness, in the sense that in some cases communities lack awareness about themselves, while in other cases there is a lack of awareness about open science practices. And finally, the lack of open science tools and services. Some communities are more mature, they have maybe a research infrastructure that support them, but others are not. And the goal is to support those communities that are not enough mature in terms of open science practices, so that we can help them doing this shift for an effective implementation of open science publishing practices in their community. And to do this, the gateway offers a community view of the OpenAIRE research graph. And for those who do not know what the OpenAIRE research graph is, you can see it as a big collection of metadata records that describe entities of the research life cycle, publications, data sets, organizations, projects, and so on. And these entities are linked to each other and forming a graph. And OpenAIRE builds this graph by aggregating metadata records from many different sources worldwide. We include also Crossref, DataCite, ORCID, and most important, a big network of institutional and thematic repositories. So what we get in the end is a graph with more than 500,000 million publications. And thanks to this graph, we address the problem of the dispersions of research products, but still it's not easy for a community to find what's relevant for it. So this is why we offer this community view, the slice of the graph that is relevant for the community. But the gateway is more than this. So you can see it as an open science toolkit, so an entry point to tools for the implementation of open science. Next slide, please. So to start with, researchers get a discovery gateway where they can explore, navigate, search all research products and entities relevant for their communities. Next slide, please. And how we do this. So the community managers or community curators, they access an administration dashboard of the gateway. And through this dashboard, they can configure the criteria of inclusions. So we apply this configuration on the OpenAIRE research graph to identify the products of the community. And those are made available via the web portal of the gateway, via the OpenAIRE APIs, and they are also published as JSON dumps on Zenodo. Next slide, please. So as you can guess, the configuration criteria are fundamental, and they are in the hands of the community manager because they are the experts in the domain and they know how to identify the research products that are relevant for them. Next slide, please. And they can do this in many different ways. So they can give a list of keywords, project grants, thematic repositories and journals, thematic Zenodo communities, organizations. However, also the simple user, so the researcher using the gateway, can contribute to grow the record of the research outputs of the community. So via the gateway, you can add the missing products and the missing links between the products. Finally, we have the OpenAIRE algorithm. So one is we call it propagation algorithm because it propagates context from one entity to another. So basically, it propagates the fact that a product is relevant for a community to the linked products. So for example, if a publication is relevant for the community because of one of the other criteria, and it is supplemented by a dataset, then also the dataset is relevant for the community and so on. And this is very important because metadata of datasets, of software is typically very poor. So it's very important that we propagate the information in this way. And then we have the full text mining algorithms, and they look into the abstracts and in the full text of open access publications to identify new information that is not explicitly stated in the metadata, such as links to projects, affiliations, document classifications, relevant research communities, related data sets, and much more. And this is all information that we can exploit to identify products of the community. Next slide, please. Then we have the tools to bridge the places where research is done, the research infrastructures, with the places where the research is published, which is the scholarly communication ecosystem. And for this, there are the Zenodo API that can be used by the services of the community or the research infrastructure serving the community to publish any type of research products. So not only publications, but also software, also data sets and workflows and protocols and so on. So publish all type of research products and make them available in the gateway straight away. And in addition, we can also provide up-to-date information about community products products to thematic repositories or other services of the community. And we can do this thanks to another service that OpenAIRE has, which is called the OpenAIRE Provide Dashboard, which targets content providers and repository managers. Next slide, please. Finally, statistics and tracking. So in the gateway, you will find tools that ease the reporting, for example, to funders. You can find information to inform, let's say, the development of open science scientific reward strategies, and to track the uptake of open science practices within the community. And those are all indicators which are configurable and can be changed and adapt to meet specific requirements a community might have. Next slide, please. So to conclude, OpenAIRE Connect delivers these configurable open research gateways for research communities, and the goal is to lower the barriers that hinder the adoption of open science practices. And it is the service by which OpenAIRE supports community building, strengthening, and empowering. And as you can see in this slide, we have already delivered 10 community gateways to community of different disciplines, and we are working already with other communities. And this results not only in the OpenAIRE Connect service to be available in the EOSC and to the EOSC community, but also each gateway will be made available via the EOSC, and so widen, let's say, the availability of services in the EOSC itself. Thank you very much.
Thank you, Alessia, for your presentation. It's great to see that you have been thinking of multiple stakeholders, including the decision makers, with the statistics and reporting that you would get from the dashboard that OpenAIRE Connect built. I don't see any questions in the chat at the moment, but that does not mean that you cannot ask, and we can answer them at the last part of the session. Thank you again, Alessia, for your presentation. We will continuing with the next presentation, which is called the European Framework for Data Ecosystem and Data Spaces. I see Mark Dietrich here from the EGI Foundation. I don't know who's going to be speaking. I have also Sebastian here, who is from Alfred Wegener Institute in Bremenhaven, who's been working on the C Data Connect. So the guys, the floor is yours.
Thank you very much. I've opened up my video. Hopefully I'll show up, and I'll be joined by Sebastian Mirek and Paco Pando in a moment. So thank you for the opportunity. Welcome everyone. I'm speaking to you mostly in the context of the EGI-ACE project, where we are integrating, if you will, data spaces, data ecosystems, data initiatives from a variety of communities. And we wanted to step back and look at the data space and ecosystem models and try to harmonize those models and the terminology in order to ensure or enable more interoperable governance standards across those projects and initiatives. So we're not looking at products. We see lots of discussion, we see lots of swirling technologies, but we wanted to take a step back and try to create a common framework. Next slide, please. So to do this, we proposed a concept to harmonize the models, namely a data exchange approach. And this is somewhat generic. It's a set of organizational policies and roles and technical specifications, all of which are intended to enable trustworthy exchange of data. And data ecosystems and data spaces are types of data exchange approach. And notably, they can, these DEAs can describe different characteristics. And most importantly, we can see visibility of data exchange approaches as being a variable characteristic which can be limited or controlled. When we look at, next slide, please. When we look at the EOSC architecture, and this is a diagram that has been used in many contexts, we can call out the presence of data exchange approaches at many different levels across EOSC. And so the concept is useful. It helps to integrate the approach that's being taken at different points. And we're working together with our colleagues, and we invite others to join us in this effort to define these characteristics so that there's comparability, compatibility, and eventually leading to interoperability. Next slide, please. So to jump into data ecosystems and data spaces, which are terms often used, I would note that our colleagues in this effort, ANIST, GBIF, and CDataNet are each, as we define it, a data space. So this is the term that the European Commission is using. And in fact, these communities are already data spaces. Coming back to data ecosystem, there's a purposeful collaboration or partnership, which is consuming, producing, and providing interoperable data and related resources. So we know these exist in the world and even in the science community in some areas. A data space, as defined by the Commission, it's a collection of fair, quality data and related resources. There are identified participants, they respect societal values, and they operate within an explicit framework of trust and governance. And a data ecosystem at the end is basically a private data space, which includes specific communities and purpose. Next slide, please. And we can put these different entities on a spectrum ranging from a point-to-point or party-to-party exchange agreement all the way to open data, which all of you are familiar with. And in between, we have lots of different instances of data exchange approaches. And so they have different characteristics as we move along the spectrum. And it's important to respect those differences. So now I'd like to hop over to our colleagues. I will first hand the mic over to Francisco Paco Pando from GBIF. So if we could advance please, to the, again, please. Thank you. Are you there, Paco?
I am. Good afternoon, everyone. Can you hear me?
Yes.
Great. So as Mark was saying, one of the data sharing communities is the GBIF, the Global Biodiversity Information Facility, which is the largest gateway in the world to biodiversity data. GBIF is an international, intergovernmental organization, and the members are countries. It has been in existence for 20 years now. It is a pretty mature community, serving right now almost 2 billion biodiversity records, and federates almost 60,000 databases. It is a much used infrastructure with a traffic around 85 billion records every month. Next slide, please. In terms of fairness of the data served through GBIF, I would say that we're pretty much on target. Every single record is indexed under a common standard, which is a common data profile, as it is the metadata provided for each data set. So in terms of interoperability, all records inside the network, the GBIF network, are interoperable as they are under the same standards. And well, regarding interoperability with other systems, it is still some work to be done. About accessibility, everything is cached, everything is downloadable by anyone, everywhere in the world, and as it is in terms of visualization. And traceability of the data, each data set is identified by a DOI, and they can be tracked, and we can build metrics on the use and reuse of the data. And right now, our frontier in terms of fairness is to provide permanent identifiers for every single record in the system. And with this, I give the floor to my colleague.
Thank you very much, Paco. So if we, I don't know who's running the slides, if we could go back one quickly. We have the ever-present FAIR qualities, but I would also point out that in our work on these data exchange approaches that we're identifying a few other characteristics, such as quality, such as trust, such as governance, community, etc. in order to characterize the different data exchange approaches, because often things are fair, but they don't actually work together well because of some of these other issues. So we need to clarify that. So moving forward, I'll present for ENIS on behalf of ENIS because our colleague Sandra Fiore could not join us. So move forward, please. Thank you. So this is a federated data infrastructure for climate models data. I think many of you may be aware of it. In fact, ENIS is part of the Global Earth System Grid Federation, which in turn is the host for the Coupled Model Intercomparison Project, CMIP, that some of you have probably seen in the news, because that's driving a lot of the analysis being done by the Intergovernmental Panel on Climate Change. So there's an external pressure on the ESGF and on INIS as the primary European partner to make data public so that it can support public discussion and discourse on climate change in preparation. Obviously, like everywhere else, we're seeing exponential growth in data. We're seeing also interesting growth and change in accessibility. Earlier versions of the CMIPs were limited. There were authentication steps. There were restrictions on commercial use, but the community over decades has learned how to share their data publicly, almost from the very beginning. So this is a long transition, and it must be respected as we consider interacting with other communities. Let's go to the next slide, please. Let's look at usage and exploitation opportunity. Another beautiful opportunity or beautiful capability of the ENIS capability is this move. They have what's called the, sorry, I have to catch up my own. So the ENIS Climate Analytics Service. So you see the two stacks of icons in the middle, client-side workflow, server-side workflow. Basically, this community has created an ability to do remote data analysis and to get away from the process of time-consuming and inefficient data downloads and often constraints on local analysis capacity. And instead, they offer a resource to do this analysis on a remote basis. So integration of infrastructure with data, services with data. So let's move on to the next of our three use cases, and that's CDataNet. And Sebastian, please.
Okay, thanks, Mark. Can you all hear me? Yeah, thanks. Perfect. Okay, so CDataNet. Now we are talking about ocean and marine data, and CDataNet is active for more than 20 years, and Europe has been building a landscape for marine data management infrastructures in the last decades. And this is based on three distinct levels, which you can see here on the left, where on the bottom, we have the base, which are the data originators. And these are thousands of parties who collect ocean and marine data. And on the top, we have the users and end users of this data from research institutes, from industry, from government, and more. And in the middle, we have the major data aggregators. And those data aggregators, they provide data management, and they generate data products, and they serve the data products. And this setup goes from raw data to validated data to data products and to knowledge. So, and the major data aggregators, which are, for example, eModNet, Copernicus, Siemens, and also here in this case, CDataNet, which includes 110 data centers from more than 34 countries. And we are already serving this data, but now in the EGI-ACE project, we will go a step further. And next slide, please. And we will provide the marine and ocean data from CDataNet, eModNet, also from Argo, to be used with our WebODV tool. And WebODV is an online tool for the interactive data analysis and visualization. And you can see some two examples here on the right, which are quite sophisticated visualizations and analysis. And they are based on validated raw data and really made from scratch. So they're really made online in this web application, and it's without programming. It's really hands-on, doing everything with the mouse and keyboard. So you can click on every point, you can change every setting, every color, every kind of figure, and create these fantastic visualizations, which can be used, for example, in publications. And in the end, the users can save their analysis or visualizations in a private workspace for later reuse or sharing. So that's the idea of the CDataNet use case. Thanks. Next slide, please. I'm done.
Thanks very much, Sebastian and colleagues. I'll do this quickly. Key points: EOSC will host multiple data exchange approaches. You can see some of the points there. We need to respect their differences. This point has been made on by several other presenters. In terms of our own efforts, we want to expand our collaboration and refine the framework we're using. So if you would like to participate, I encourage you to contact me at the email address there. Next slide, please. And I'd like to thank the supporting funding agencies and projects that have contributed to this activity. So I'm done. Thank you very much for your tolerance.
Thank you. Thank you. Thank you, Mark. Thank you. We're just in time, I think, back in on the track. It's always interesting, and it's always grateful to see the complexity of the data management taken away from the users and giving them the chance to do the things that they do the best, analyze the data and produce the scientific outputs from this. We'll continue right next to the next presentation. It's the technical interoperability of open science knowledge graph for scholarly communication, and it will be given by Andrea Mannocci. Andrea is a data scientist within the framework of the EU project OpenAIRE Advance, where he takes part in the construction and analysis of OpenAIRE research graph. His research interests span from development of open science enabling technologies to the meta science, or the science of science and analysis of research as a global scale socio-technical phenomenon. Andreas, the floor is yours. Andrea?
Yeah. Can you hear me? Okay. Yeah, I was muted probably. So in this talk, I'm going to deal with the interoperability of open science graphs and why they are relevant to the European Open Science Cloud. Next, please. So as we all know, like, forgive me for being repetitive, but we know that the open science movement requires researchers to publish a bunch of different entities that go beyond the traditional PDFs, and which include software ideas, tools, protocols, methods, and all kind of results, software and data, and also all the relationship that connect these entities together and deposit them in the metadata that are relative and relevant in authoritative registries. And all this information results scattered in a plethora of different services across the web. Next, please. And as a matter of fact, we witnessed a rise of many services and different platforms that spawned across the web. So to contribute and or consume such academic information, scholarly nature information, and I'm pretty sure that you can recognize here plenty of logos and friendly faces, and it gives you this is not an exhaustive list. It's just a snapshot of the major players here, and it gives you the extent of how scattered and fragmented this domain is. And also considering that Microsoft Academic has been marked for retirement by the end of the year, you also get a sense that not everything is eternal, and all these initiatives might cease to exist. So it's very important to keep the knowledge and all the effort that has been done flowing. Next, please. So why open science graphs are relevant to the EOSC? The OpenAIRE research graph happens to be at the core of the EOSC Future Research Catalog. As a matter of fact, the current research catalog that has been developed in EOSC will flow into together with the OpenAIRE research graph into the future research catalog, putting together services datasets and all the other relevant research entities that are included in the OpenAIRE research graph. Next, please. So what we would like to have is an open science graph interoperability framework where the EOSC research catalog, where like the OpenAIRE research graph is based on that, is connected and capable of flowing of sharing seamlessly information flow across the relevant stakeholders, and which are here I grouped in other scholarly communication graphs or knowledge graphs, either national or thematic, and other PIT graphs, such as the Freya PIT graph. So it would be very important to have, next please. It would be very important to have such a framework for interoperability so that we can capitalize on synergies and non-negligible efforts for content acquisition, integration, and enrichment that has been performed locally at the different initiatives and the different open science graphs and knowledge graphs around it. So to gather a holistic view of science and turn the EOSC as the main backbone for scholarly communication and open science. And this can be achieved by agreeing upon a common ground, lingua franca, so to support the information flow across two levels of abstractions. On one side, we have the information model, and it's all about trade-offs, because we need to maximize the information exchange and flexibility, because probably addressing all information exchange would affect flexibility too much. And so it's important to find the right balance between the two edges. And the other level of abstraction is technological. So we need to find the suite of technologies that enables us to do this kind of to reach this kind of objective. We start from a positive story, which is Scholix, is RDA success story, as a matter of fact. And even though Scholix is a protocol that enables the exchange of literature data linking, and it's a much more simple scenario, because the information involved it's much more limited than the one that would be involved in the whole EOSC concept and what context and what I was referring before. Next, please. But we need to start from somewhere. So where do we set sail in this journey? As I was saying, Scholix is the first part. Then, as Alessia was mentioning before in her presentation, in OpenAIRE we have experience for example, with the OpenAIRE broker, which is part of the content provider dashboard, to these, supporting this kind of information exchange. Then we have supranational data models such as Serif that we can draw from, and we can like try to draw from their experience and try to combine everything together. Or the OpenAIRE guidelines, the service description language of EOSC, and from a technical standpoint, we have enabling technologies such as RDF, SparkQL, and GraphQL that in principle can be leveraged, so to achieve these information flow back and forth across different open science graphs. Next, please. There's within RDA, the interest group named OSG for Fair Data, and the related working groups that we have yet to launch is going to be a venue for discussing and like trying to build together these things grounds up. And within the EOSC, we find an optimal channel for experimentations, because we have the OpenAIRE on one side and other services that we know and we can experiment with, such as Open Citations and these other three that we already collaborated with. And next, please. In our first effort in this direction, which is a position paper that we published last year, and it's basically in this paper we just draw some very preliminary work, providing a classification framework for OSGs so that we can at least put them side to side across 7 dimensions and see how they match and how they differ, and then we provide the funding reasons, so to foster open science graph interoperability. Yeah, so yeah, please feel free to download that and have a look at the paper if you're interested in that. And next, please. And that's all from my side. I hope I've been in time.
Thank you, Andrea, for the presentation and for keeping it in time, and of course for the effort that you are doing on the integrating of the open science graphs. I would now go to the last presentation, so we will have enough time to finish before going back to the main room. The RELIANCE extending the EOS capabilities. Raul Palma from the Poznan Supercomputing Networking Center. Raul is actually here with his mandate as the coordinator of the RELIANCE project, with his experience of 16 plus years in research and development in different areas like artificial intelligence, knowledge representation, semantic data integration, discovery, reasoning, open and linked data. He's the head of data analytics and semantics department at the Poznan Supercomputing and Networking Center. Raul, please, the floor is yours.
Yes, thank you very much for the introduction. So I will just give an overview of what are we trying to bring here into the EOSC in regarding the some kind of advanced or on top services to support the research life cycle management in different communities, but especially we are focused in the earth science community. So RELIANCE basically aims to extend the EOS capabilities with a set of services that are interconnected between each of them. Of course, there are leveraging also other different EOS services, and that they are in alignment with the EOS interoperability framework. So that's also very important for us. So we are adopting some kind of holistic research management approach. That means that we are considering the whole research lifecycle as a first-class entity. And based on that, we are going to enhance like the discovery and access to the research data and results, but also particularly including Copernicus data, because we are very interested in the earth science, but also to improve the extraction of relevant information while promoting the fair and open science principles. We will pilot and demonstrate our services in 3 different earth science communities, and then we will engage others via an open call that we will be launching soon. And we plan to really, at the end of the day, foster the reuse of Copernicus data. So in the slide, you can see all the partners of the consortium, and TSMC is the coordinator. Next slide, please. Yeah, okay, so briefly, I would just summarize here the objectives. So basically, one is the provision of the suite of services for the life cycle management. Second one is the integration with EOSC and the extension of the EOSC capabilities in that direction. The third one is regarding the demonstration and community engagement. And the fourth one is regarding the increased use of Copernicus and in general EOSC as a whole. Next slide, please. Okay, so yeah, so going now into more details here. So the RELIANCE basically portfolio is based on 3 key and complementary technologies that are conforming what we call the pillars of our ecosystem. So first of all, we have research objects. They are basically the overarching mechanism to manage the scientific research activities and connect associated resources. So this is some of the, the base, the core of our services is based on that. So this is like technology behind. There are services that are already providing the technology. This is Arrow Hub. And there are, of course, all the models behind that, which is a very active initiative that is Arrow Crate. Next one is the data cubes technologies that are used basically for the efficient and scalable access to Earth observation data. And also we have some very strong player here to provide these capabilities, the Adam platform. And finally, regarding the text mining, which we are going to use basically to extract machine readable metadata from the resources in the research object in order to, structure information, but also to find new information that is also supported by one of very strong competitors in this area. And so going into the next slide, please. I will go into more details into what is research object, because as I said, this is like the backbone technology behind RELIANCE. So perhaps some of you already heard about it, but basically research objects are kind of rich information objects that aim to account, describe, and share everything about your research, including how the things are related to each other, of course. So we heard already some presentations talking about the connections, the links between resources. Of course, research objects are doing that kind of things, but it's also keeping track of the whole research evolution. So how did you come on to bring into these resources? So we are able to keep the track of the evolution of this. Is kind of a living object that you can use during the whole research life cycle. So you can have in there, of course, some resources like data, the methods, the publications, the workflows, anything that is relevant for your scientific investigation. And most importantly is that at the end of the day, these research objects are also citable. They are identifiable. They have a permanent identifier associated that you can use to refer and also to share to that. So next slide, please. Yeah, so basically here you can see what is like the main high-level overview of the service logic and the interconnection with EOS that we have in RELIANCE. So in the diagram, you see basically the main services that I was just mentioning before. Basically, they are exposed in a set of RESTful APIs, some kind of Python libraries that will be used to communicate between them, but communicate with other services. And most importantly, also to be able to be leveraged by different interfaces. So at the end of the day, we envision the case where scientists might be able to use different applications, but they will be using the same backbone at the end to connect all of these resources via the research object. So here, for example, we also see that we are planning, of course, to connect to some of the EOSC services here, including, of course, the single authentication services, but also services for the storage, services for computing, and other services for data management as well. This is the plan that you can see on the right-hand side. If you go to the next slide, please. Yeah, okay, and this is the most important one. So what is the role of all of this in the context of the EOSC and other services that are related to what I was just saying? So basically, RELIANCE services are planning to become some kind of bridge between different kind of existing EOSC services, but also existing services outside of the EOSC as well, where you will be able to connect the different resources that are used and produced during the whole research life cycle, of course, from the data that was used to the method that were applied to process and analyze those data, but also to the research infrastructures where those methods and the data are run or are being hosted, of course, to the people that are involved in the execution of all of these investigations, and at the end, of course, to the publications generated from this investigation. So everything can be at the end, encapsulated, aggregated into the research object. By itself, it's again keeping the track of all the evolution of what happened. So this is actually are the key potential enabler to support the implementation of the FAIR practices and the open science principle into the day-to-day management of your own research, sharing not only the resources, but also a systematic capture of the life cycle. So for example, during the evolution of your research, you can generate snapshots of this research object that capture what was the status of your research at a particular point in time. You can share this, for example, for review, get some feedback from people. And you can also disseminate this in platforms like Zenodo, like B2Share. So it's possible, of course. We are making these connections, this flow between all the different platforms that are already in EOSC to make not only the connection between existing artifacts, but also to deposit. So we are not just consuming, but we are also producing into the EOSC other platforms available as well. And these are some of the key benefits and impact that we can have in the EOSC as well. Next slide, please. Okay, so just to briefly mention here, just to finalize, these are the main communities that we are bringing into EOSC. They are already users, a few of them are already users of research objects from previous projects. They are very happy to bring that into the new level of the EOSC. And basically, we are going to collaborate now with the sea monitoring communities. This is represented by CNR, ISMAR in Italy, with the geohazards community that are dealing with the super sites, volcanic and seismic hazards, and the atmospheric community that is from the Norway. Apart from that, of course, we will launch, like I said, an open call to engage more communities. This will be called the RELIANCE Challenge. What is important at the end, just to conclude, is that all of the use cases that we will be generating from this and showcasing the services from RELIANCE will be now, of course, in cooperation with earth science communities, but the services themselves can be easily adapted and reused in other domains. And with that, I conclude, and I am very happy to take any questions from your side.
Thank you, Raul. We do have a couple of more minutes until the end of this session. Since I don't see any question here, I would like to use the last couple of minutes, first of all, to thank the presenters, thank Nadia, Alessia, Mark and his team, Andrea and Raul, for their wonderful presentations on trying to make EOSC more interoperable and for the benefit of the users, which is more important, for the benefit of the users. If I can wrap this in a couple of minutes, we talked about the DICE project and the work that is done on interoperating, bringing data and the computing close for the users and generating use cases that will make EOSC more attractive to new users, to improve data service composability and interdisciplinary reuse. Then we talk about the OpenAIRE Connect, which delivers the open research gateway for the research communities for a very important goal to lower the barrier that hindered the adoption of open science. Then we had the team presentation from Mark and his team about the data ecosystems and data spaces. I picked a very important line from this presentation. Although it addresses a very complex matter, I would simplify it in I picked up a nice line by Mark, being making data beyond fair with quality, trust, and other attributes. So fair is just a starting point. We should go up and beyond that with the excellent examples from the three data infrastructures in three different areas. Then we have the open science graphs, which are envisaged to be in the core of the EOSC research catalog that will enable us to connect the knowledge there is and help its preservation somehow beyond the existence of individual elements. And finally, we had the RELIANCE presentation, which focuses on the research objects and that help us manage the lifetime of our research. Research objects are seen as the key enablers to support the implementation of the EOSC FAIR principles. I hope this wraps it well. I hope everyone is satisfied from what they heard in this presentation. The room will close in less than 2 minutes, I think, and we will all be back at the main room where we will see the recaps of the other 4 breakout sessions, and we'll give I will give the one from ours. Thanks again, everyone, for participating this afternoon. See you in the main room.
Thank you.
Thank you.
Thank you. Bye.